Imagine a world where humans can lift hundreds of pounds effortlessly, walk without pain regardless of age or injury, or complete tasks with superhuman precision and endurance. This isn't science fiction. It's happening now thanks to robotic exoskeletons. Welcome to a deep dive into one of the most revolutionary advancements in technology, robotic exoskeletons for enhanced human performance. Before we get started, don't forget to subscribe to our channel, like this video if you find it interesting, and hit the notification bell so you never miss an update on the latest in futuristic tech. Also, we'd love to hear your thoughts and questions in the comments section below. Robotic exoskeletons are essentially wearable machines that augment human capabilities. Imagine an outer shell, like a suit of armor, but instead of just providing protection, it enhances physical ability. These devices are powered by a combination of actuators, sensors, and sophisticated control systems that synchronize with the wearer's movements to provide additional strength, stability, and endurance. They are no longer just the stuff of comic books and movies. They are evolving rapidly and finding their place in various sectors, from healthcare to military to industrial application. One of the most transformative impacts of robotic exoskeletons is in the field of healthcare. For individuals with mobility impairments, such as those suffering from spinal cord injuries, these devices offer the possibility of walking again. For example, consider the case of a person who's been paralyzed from the waist down. Traditional wheelchairs are restrictive and can lead to a host of secondary complications such as muscle atrophy and pressure sores. A robotic exoskeleton can enable such a person to stand up, walk, and even climb stairs, thereby significantly improving their quality of life. The exoskeleton achieves this through a series of sensors that detect the user's intention to move, which then triggers actuators to initiate and maintain the walking motion. This not only provides mobility, but also helps in muscle strengthening and improves cardiovascular health. Beyond individual mobility, robotic exoskeletons are also making waves in rehabilitation. Physical therapists are using these devices to help patients regain lost functions through repetitive motion exercises. The exoskeleton can be programmed to assist with movements, providing consistent and precise repetitions that are crucial for effective rehabilitation. This is particularly beneficial for stroke patients who need to rewire their brain functions to regain motor skills. The robotic exoskeleton provides the necessary support and resistance to facilitate this neural retraining, making the rehabilitation process more efficient and potentially faster. In the industrial sector, robotic exoskeletons are revolutionizing the way work is done in environments that require heavy lifting or sustained physical effort. Imagine construction workers, factory employees, or warehouse operators who need to lift heavy objects repeatedly throughout the day. Traditional methods can lead to severe injuries and long-term wear and tear on the body. A robotic exoskeleton can mitigate these risks by distributing the weight more evenly and providing mechanical assistance to make lifting easier. For example, a worker wearing a robotic exoskeleton can lift a heavy object as if it were just a fraction of its actual weight. This not only enhances productivity, but also significantly reduces the risk of injury. The military is another arena where robotic exoskeletons are making a substantial impact. Soldiers are often required to carry heavy loads of equipment, sometimes exceeding 100 pounds over long distances and challenging terrain. This can lead to extreme fatigue, reduced effectiveness, and a higher risk of injury. With a robotic exoskeleton, a soldier can carry more weight with less physical strain, enhancing their endurance and operational efficiency. These devices also provide additional stability and protection, making soldiers more resilient in combat situations. Research and development are ongoing to make these exoskeletons lighter, more durable, and more integrated with other military technologies to create a seamless combat system. In sports and athletics, robotic exoskeletons are opening up new frontiers. Athletes are using these devices for training purposes, where they can push their physical limits safely and recover from injuries more effectively. Imagine a runner wearing a lower body exoskeleton that allows them to train at high speeds without the usual risk of overuse injuries. This could lead to new records and redefine the boundaries of human performance. Additionally, exoskeletons can also be used in adaptive sports, providing opportunities for individuals with disabilities to compete at high levels. The technology behind robotic exoskeletons is incredibly sophisticated. These devices typically consist of a frame made from lightweight but strong materials like carbon fiber or aluminum. Attached to this frame are actuators, which are the mechanical muscles of the system. These actuators are usually powered by electric motors or hydraulics and are controlled by advanced algorithms that process data from multiple sensors. These sensors can include accelerometers, gyroscopes, force sensors, and even biosensors that monitor the wearer's muscle activity and intentions. The control system uses this data to provide real-time adjustments, ensuring that the exoskeleton moves in harmony with the wearer. Powering these exoskeletons is another challenge that researchers are tackling. Most devices rely on batteries, which need to be lightweight yet powerful enough to last through extended use. Innovations in battery technology, such as lithium, ion and solid-state batteries, are helping to meet these demands. Some exoskeletons are also exploring alternative power sources, such as fuel cells or even kinetic energy harvested from the wearer's movements. One of the fascinating aspects of robotic exoskeletons is their potential for customization and adaptability. No two human bodies are exactly alike, and the needs of users can vary widely. Advanced exoskeletons are being designed to be highly adjustable, allowing for a tailored fit that can accommodate a range of body sizes and shapes. Additionally, these devices can be programmed to adapt to different tasks or levels of assistance. For instance, an exoskeleton used for heavy lifting in a warehouse can be adjusted to provide more support during peak hours, while a medical exoskeleton can be fine-tuned to match the specific rehabilitation goals of a patient. The economic impact of robotic exoskeletons is also worth noting. As these devices become more widely adopted, they have the potential to reduce healthcare costs by preventing workplace injuries and improving rehabilitation outcomes. In industrial settings, they can boost productivity and reduce the costs associated with injuries and lost workdays. For the military, the improved efficiency and reduced injury rates can lead to significant savings and operational advantages. The market for robotic exoskeletons is growing rapidly, with new companies entering the field and existing players continuously innovating to improve their products. However, despite the impressive advancements, there are still challenges to overcome. One of the primary issues is the high cost of these devices. While prices are expected to decrease as technology advances and production scales up, the initial investment can be prohibitive for many potential users. There are also regulatory hurdles to navigate, particularly in the medical field, where rigorous testing and approvals are required to ensure safety and efficacy. Additionally, integrating these devices into existing systems and workflows can be complex and requires careful planning and training. Ethical considerations also come into play when discussing robotic exoskeleton. As with any advanced technology, issues of accessibility, privacy, and potential misuse need to be addressed. Ensuring that these devices are available to those who need them most without discrimination is crucial. There are also concerns about the potential for enhanced human capabilities to create inequalities or be used for harmful purposes. Establishing ethical guidelines and regulations will be essential as the technology continues to develop. Looking to the future, the possibilities for robotic exoskeletons are almost limitless. Advances in artificial intelligence, machine learning, and robotics will continue to drive innovation, making these devices more capable, affordable, and accessible. We can envision a world where exoskeletons are a common sight, used in everyday activities to enhance human abilities and improve quality of life. From helping the elderly stay active to enabling workers to perform tasks more safely and efficiently, the potential applications are vast and varied. In conclusion, robotic exoskeletons represent a groundbreaking leap in technology that has the potential to transform numerous aspects of our lives. They offer new hope for individuals with mobility impairments, provide powerful tools for rehabilitation, enhance productivity and safety in industrial settings, and bring new capabilities to the military and sports arenas. As the technology advances and becomes more integrated into our daily lives, we can look forward to a future where human limitations are redefined and new possibilities are unlocked. Don't forget to subscribe to our channel, like this video, and hit the notification bell so you never miss an update on the latest in futuristic technology. We'd love to hear your thoughts and questions in the comments below. Thanks for watching, and see you next time.